Today we'll discuss first DNS, domain name systems. Domain name systems is basically it's the internet's directory service, right? So domain name system is the internet's directory service. So let me try to explain it with the help of an analogy. For example, in our real life, we can identify people either by using their names or by their social security numbers, by their passport numbers, right? Or maybe using their CNIC, right? But ordinary people prefer the more the more mnemonics. Means using the birth certificate names rather than social security numbers and CNICs. So in real time scenario, I would prefer calling you by your name, right? So I'll be taking help of mnemonics to call a person, right? So just as humans can be identified in many ways, so too can internet host, right? So similarly, we can identify an internet host uh, with a mnemonic, right? For example, yahoo.com or say CNN.com. These are the host names, right? And these host name, CNN.com or Yahoo.com, are just like your name's mnemonics, right? And yes, we know that we can also identify an internet host with the help of an IP address, right? Why? Because this, mnemonic or this host name, CNN.com or Yahoo.com, it does not give me detailed information about the location of the internet host. For example, using CNN.com, I cannot reach the CNN server, right? For that, I need to have, I need to have this IP address here, right? Either 32-bit when I talk about IP version 4 or 128-bit when I talk about IP version 6. The second reason for using this IP address to identify the location of the internet host is, and not using these mnemonics, is because these mnemonics consist of variable length alphanumeric characters, right? For example, the length of Yahoo is different from the length here in this host name CNN, right? And it can contain alphanumeric characters as well, and that's why hosts are identified by so-called IP addresses, and the important thing is we can use these IP addresses to reach the location of the internet host, right? So in order to, and obviously, being humans, what we will prefer? We will prefer IP address, or we will use mnemonic or host name to address an internet machine or an internet server. Obviously, the humans prefer what? Host names or mnemonics. But in order to reconcile these preferences, we need to have a directory server, directory service, just as DNS. What it will do is it will translate host name to IP addresses. So what this directory service or this DNS does for us is that it translates this host name, CNN.com, to IP address, right? And Um, um, and you can say this is the main task of the internet's domain name systems, DNS. That is to translate the host name to the IP address. Why? Because because we prefer to use mnemonics in addressing host names. So we can say that a domain name system is a distributed database. So what it is a it is a distributed database that has all these mappings, right? Which is implemented in in the form of different DNS servers or name servers, right? So we have implemented this directory containing this mapping of host names and IP addresses on a hierarchy of DNS servers, right? And different application layer protocols, allows hosts to query these, distributed uh, servers or hierarchy of servers or distributed database to get what? To get um, the IP address against the name, means to have this mapping from address or name translation, right? So variety of the application layer protocols makes use of, or they employ DNS. For example, if I talk about the application layer protocol, if I talk about HTTP, so HTTP makes use of what? It makes use of DNS. FTP, since we have covered these protocols, or talk about SMTP. So all these and many other application layer protocols makes use of DNS to get this mapping of address and name, or get this address name translation, right? Obviously here it's important to note that this DNS adds an additional delay, and it can be sometimes substantial, that the desired IP address is often cached in a nearby DNS server in order to avoid this delay. For example, if I want to know the IP address against a name, so I have to query our DNS server, and this DNS server is maybe not near me, right? So this is there is obviously a delay involved here, right? So in addition to this translation of names into IP addresses, it also provides us other very important services. For example, it provides us um, it provides us host aliasing, right? DNS, this domain name systems, a distributed database containing this mapping of IP addresses and host names, also provides us other important functionalities such as, number one, host aliasing. Okay, a host name, with a complicated, or a host with a complicated host name can have one or more, alias names. Usually, a host name is not that simple; it's complicated. For example, a host name may look like similar to this one: relay one dot west host dot enterprise .com, right? So, and usually such a name is called canonical host name. What we call it? We call it um canonical host name, right? And obviously, this is more complicated as compared to a simple host name. So what I can have is um, um, I can have one or more alias names for this canonical host name. For example, I can use this name to address, host name to address this host. For example, enterprise.com. Enterprise.com, or I can use another alias, for example, www.enterprise.com, right? Since our host name is canonical, right? Uh, and in order to use a simple host name, we can have one or more aliases such as enterprise.com or www.enterprise.com, right? So it's very important functionality of DNS is to it not only obtains the canonical host name for a supplied alias name, but it also obtain the IP address. So what happens basically is, so when we write enterprise.com, so DNS does what for us? It get us this canonical name as well as the IP address. Okay, and the second important service provided by DNS is mail server aliasing, right? Mail server aliasing. Okay, so email addresses should be mnemonics. We know that, right? Like hotmail.com, yahoo.com, right? But the host name of Hotmail server is more complicated, right? It is again maybe something similar to this. Say relay one dot west host dot hotmail dot com, right? So again, we need to do what? So we need to have, or we can allow a company's mail server and the web server to have the identical host names, like gmail.com or like Hotmail, or hotmail.com or like enterprise.com, right? Can be used for what? Can be used for email as well as for the web server as well, right? So here we need to have a mechanism using which we can permit this. What? Using the same uh, you know host name for both web and email server or mail server, having the identical host names. And this is done using what? Using MX record, and that we'll cover in a minute, right? So, mail server or DNS using MX record allows a company to have identical host names for mail server as well as for the web server. Okay, and the third important, service that is provided by DNS is load distribution. Load distribution. So see, a DNS also performs load distribution among the replicated service, such as web servers. You know what? The busy sites such as CNN.com are replicated over multiple servers. So there is no one server implementing CNN.com. There is an array of servers. There's a form of servers implementing a busy site, right? So when a replicated server is addressed, or when I try to access CNN.com, a set of IP addresses is returned that are associated with one canonical host name. I repeat. So since I maintain, CNN.com or more than one servers, so a set of IP addresses is thus associated with one canonical name. So when I address CNN.com, what this hierarchical DNS database does is that it returns me a pool of IP addresses mapped to a canonical name. But when it returns me or it gives me a list of IP addresses, it shuffles it rotates it so that the load can be distributed on these evenly distributed on these servers, right? So it does not only give me the list of the IP addresses mapped against the canonical name of, say, for CNN.com, but it also rotates it as well, right? So a DNS, query or a reply message is sent within UDP datagram. So remember, up till now, whatever the applications at the application layer we have discussed by using TCP, right? So this DNS domain name systems makes use of UDP at the transport layer for the DNS query and reply messages. And these, DNS queries and reply messages are sent over on port 53. Okay. So if we look at, if we look at the implementation of a simple DNS design, it could have been one DNS server. Now the question is how I will implement this, the mapping of IP addresses and host names. So one simple implementation could have been like that. I have one DNS server, right? And every machine, can access or can connect to this simple or single DNS server. But what do you think? What are the problems with a centralized design here? If I have one DNS server, so the problem can be a single point of failure. So if I implement DNS on one server, the one problem can be it's a single point of failure, right? So we are just talking about the design possibilities. So one design possibility is that I'm implementing it on one server, and the drawback of such an implementation is single point of failure. Single point of failure. Okay, what else? Then maybe the traffic volume is huge on this one server. There are millions and billions of requests or query DNS query messages. So we may end up having a huge traffic volume. Okay, what else? Maintenance would be an issue, right? So if we have one single server, then the problem is that how we gonna um, maintain it, right? Then maybe it's not it's not a distant centralized database. I mean, maybe it's not close to all the queuing or all the hosts sending query messages. So distance is another issue, right? So this means one single DNS server is not a good solution, right? So that's why we need to implement domain name systems as a distributed and hierarchical database, right? Where there are three classes of DNS servers, right? So we have this root DNS servers, right? Then we have top level domain TLD, top level domain DNS servers, and where we have this authoritative uh, you know DNS servers, right? So we have root DNS servers, we have top level domain DNS servers, and we have authoritative DNS servers, right? And then we also have local DNS servers, right? So DNS is implemented as a distributed and hierarchical database. Let's talk about these servers in a detail. So first we have, the root DNS servers. There are 13 root DNS servers, right? Around the world, distributed, um, uh, you know, around the world, and each, of these 13 root DNS servers is actually a network of replicated servers, right? So you can see here each site have, uh, other, or you can say a network of DNS servers. So there are in total, there are 247 root uh, servers. Okay, and that I'm talking as of fall, as of fall 2011, right? So there are total, 240. Obviously, there are 13 root name DNS servers, each having a network, and there are total 247 root servers as of fall 11, right? And then, what happens is that we first contact the root DNS server. The root DNS server is first is contacted to get an IP address of a specific uh, server, and then this root DNS server forwards it to top level domain server. Then the top level domain server forwards it to authoritative DNS server. That we'll see in a minute with the help of an analogy. Let's try to understand first that what is the main functionality of each of these servers in this hierarchy. Then we have top level domain server, right? So top level domain server is responsible for top level domains such as .com, .org, .net, .edu, etc., etc., and importantly, all of the country top level domains such as UK, uh, FR, PK, CA, right? And then we have. Uh, then there is a company known as with the name VeriSign Global Registry Service, that maintains the top level domain servers, means uh, .com, .org, .net, etc., etc., all these different domains. And then we have the authoritative DNS server, right? So this is an organization, the authoritative DNS server. It houses the DNS records, right? So it's organization's own DNS server, and it provides what it provides the host name to IP mapping of organizations' addressable hosts that are addressable to the other host on the internet, right? And then we also have, it's not listed here, but we also have the local DNS server. Within the organization, we have division into different departments, and there are different hosts that are accessible. So we can have the local DNS servers as well, and this hierarchy, so that we can access that specific machine. So let's try to understand it with the help of a scenario that how our DNS query, either it's recursive or iterative, is generated, and a response is received by the other machine.